Okay, can you see my screen?
Yeah.
In 1956, Hugo Steinhaus, mathematician, invents k-means. Today, I present to you k-means for YouTube's top 5 data science channels. Over 617,000 comments, 11 million likes, and 491 million views, assuming no labels and 3 attributes. May the best K win.
Thank you. All right, I'm glad to be here today to present my capstone project on optimization of k-means algorithms for YouTube's top 5 data science channels. My name is Wintta Ghebreiyesus, and I am a PhD aerospace engineering student at Ryerson University. And my research is on reducing aircraft cabin noise for passengers. My interests are in automatic speech recognition, NLP, and general ML, as well as AI for aerospace applications. So a little bit of a background into k-means. K-means is a clustering technique that is used to determine the relationships between subgroups in a data set. The main benefit is for grouping similar objects together, where K in k-means represents the number of clusters within the data. I have also considered the mini batch, which is a version created in 2010 by David Scully, with a target of larger data sets to help reduce computational cost. And this version has subgroups, which are called mini batches, that gradually move the centroids after each iteration. So the definition of our problem here is to demonstrate that unsupervised k-means learning techniques can be successful in determining the popularity groupings of a YouTube dataset containing 5 channels. The criteria is to minimize the overlap between adjacent subgroups, to save the training time, and ultimately to find the best number of clusters for the dataset. So here you can see that the original data on the left contained 11 attributes. The next step was to clean it up to only include the columns of the video ID, the number of views, the number of likes, and the number of comments. The main 3 are views, likes, and comments because they are simple to compare and quantify. After this, the dataset file was further separated into individual train and test files, with 75% of the data going to the training set and the remaining 25% for testing. So the top 5 data science channel dataset, as you can see here on the screen, is the main subject of this study. The unlabeled data was first plotted using the numerated video ID and each attribute, which are the views, the likes, and the comments. And the reason for this is to understand the scale. So prior to the clustering approach, it made sense to normalize this information, which is actually not contrary to, but it's a complement of what we saw in the text. The usefulness of k-means is that it could better analyze and sort the unlabeled data according to the clustering groups. So here, k-means, I'll say that the centroids can move around a little bit for each iteration in the process, and this will be described a little later. But you can see here that we've successfully identified 5 cluster centers in gray on the right there. So that's going from the unlabeled data to now the labeled data. This image here was obtained from slide 6 in the lecture notes. I would like to highlight how it was applied to this project. So the input for the K values ranges from 1 to 101, and the training data set from 0 to 1,380. The output is the centroids within the same range as K. The initialization parameter, I've left that alone. It's kept at the default value of 10. And lastly, nothing was altered in terms of the assignment expectation steps, as well as the refitting and maximization steps. So here were the three metrics that I used: time, inertia, and silhouette score. And then now moving on to the results, we found that mini batch outperforms the regular k-means in terms of computational cost, and that it is actually, the trade-off is that it's undesirably high inertia. And when comparing the number of clusters, I plotted a 2D pairwise analysis for visualization. It could actually be 3D, but here we're just looking at the number of views and the number of likes. And so on the image the images on the bottom left and right can see where k is too small versus where k is too large. And we know that the ideal value lies somewhere in between. And I also did an analysis for finding a better value of k, which is looking at the elbow technique as well as the silhouette score. And the silhouette score, we found a local maxima of k equals 5. So now in terms of moving forward, it was found that this approach was successful in grouping the data and using the three main parameters of views, likes, and comments, as well as comparing the regular k-means with the mini batch. Future work can look at maybe a semi-supervised approach and perhaps including more statistics into the data set, as well as different k-means initialization. And lastly, comparing hard versus soft clustering studies, this can be carried out as well. So thank you.